In 1946, a locomotive meant to shatter speed records instead tore itself apart at a claimed 142 miles per hour, surpassing not just its limits, but its own engineering promises. The official history of this machine is one of ambition and destruction, but inside the vanished world of the PRR T1 lies an untold secret. Why would America's most advanced steam engine be designed to fail beyond the speed it was guaranteed to survive? Understanding that answer exposes the hidden flaw that doomed not just a fleet, but an era. Baldwin's engineers set out to create a locomotive that could outpace anything on the rails, but the T1's most advanced feature, its Franklin poppet valve system, carried a hidden limit. These valves, the heart of the engine's power delivery, were rated for continuous service up to 100 miles per hour. That guarantee appeared on every engineering drawing and echoed in every shop manual. The promise was clear: above that threshold, the risk was no longer Baldwin's responsibility. Inside the T1's massive steam chest, each poppet valve opened and closed with mechanical precision, controlling the flow of superheated steam from boiler to piston. At 100 miles per hour, the 4 cylinders devoured over 15,000 cubic feet of steam every minute, each valve cycling hundreds of times per minute without pause. This relentless motion pushed the metallurgy to its edge. Every increase in speed meant more cycles, more heat, and more stress. As the T1 crept past its design envelope, metallurgists at Baldwin and Franklin Railway Supply started to see a pattern. Valves would develop hairline cracks, sometimes invisible to the naked eye, that grew with each mile. The culprit was metal fatigue, tiny imperfections deep in the steel, driven to failure by the pounding rhythm of high-speed operation. When a valve fractured, it could jam open or closed in an instant. If it stuck shut, exhaust steam had nowhere to go. Pressure inside the cylinder spiked, sometimes enough to blow seals or rupture a line. In the best cases, power dropped away and the engine limped home. In the worst, the locomotive was dead on the rails, trailing a plume of wasted steam. Shop crews learned to dread the sound: a sudden, sharp, metallic snap, followed by a drop in power and the smell of overheated metal. Maintenance records from the era describe frantic repairs, with mechanics racing to replace shattered valves before the next run. The official paperwork always circled back to the same number, guaranteed at 100 miles per hour. Beyond that, every mile was a gamble. For the engineers, the temptation to push harder was always there, but the price was written in fractured steel and lost time. The T1's poppet valves, meant to usher in a new age of speed, instead revealed the limits of 1940s engineering. The promise of 100 miles per hour was not ambition, it was the edge of what the metal could survive. Every run above that speed was a step into the unknown, and the consequences were as real as the broken parts left behind. Engineers faced a new kind of challenge each time they opened up the T1's throttle. The Duplex drive, with its 2 sets of driving wheels and cylinders mounted on a single rigid frame, was supposed to deliver power more smoothly than any locomotive before it. But in practice, this innovation introduced a stubborn, unpredictable problem: slip. As soon as the train reached higher speeds, often above 80 miles per hour, the massive driving wheels could lose their grip, spinning wildly against the rail. The locomotive's full force, instead of pushing the train forward, turned into a shower of sparks and a violent shudder that rattled the entire machine. The T1's 4 80-inch drivers, arranged in 2 independent sets, split the engine's power between front and rear. In theory, this reduced the pounding force on the rails and allowed for lighter, faster-moving parts. But the split drive also meant that each set of wheels could behave differently, especially when the rails were slick or the throttle was handled too aggressively. An engineer had to balance the throttle with surgical precision. Too much steam, too quickly, and one set of drivers would break loose, forcing the crew to back off and try again. The process was nerve-wracking, demanding constant attention and a feel for the machine that few engineers ever truly mastered. Complicating matters further, the T1's most delicate gearboxes and synchronization mechanisms were hidden behind gleaming Art Deco streamlining. The shark-nosed casing that made the locomotive a symbol of modernity also trapped heat and blocked access to the very parts that needed the most frequent inspection. Maintenance crews, already frustrated by the unfamiliar duplex arrangement, found themselves reaching for cutting torches just to get at a stuck linkage or a misaligned rod. Each repair left scars on the locomotive's streamlined shell, a visible reminder of the conflict between style and serviceability. For the crews, the T1 was both a marvel and a menace. On paper, the duplex design promised a new era of speed and efficiency. On the rails, it delivered a daily struggle with physics, a constant battle to keep steel wheels gripping steel rails, all while the heart of the machine remained locked away behind its beautiful but unforgiving armor. In the early 1940s, the Pennsylvania Railroad boardroom faced a dilemma that went far beyond technical ambition. Wartime traffic had pushed the limits of the existing fleet. Trains grew longer, schedules tighter, and the old K4 Pacifics, once the pride of the line, now struggled to keep up. Doubleheading became standard, 2 locomotives and 2 crews for every express, burning through coal and manpower at an unsustainable rate. The cost of inefficiency mounted with every mile. Meanwhile, rival railroads paraded their own innovations. The New York Central's Hudsons and the massive Union Pacific Big Boys made headlines with power and speed, while diesel streamliners began to steal the spotlight. Pennsylvania Railroad leadership saw a crossroads: modernize or fall behind. The answer came in the form of a bold wager, a new class of locomotive that promised to do the work of 2 K4 locomotives, run faster, and restore the railroad standing. The commitment was staggering. 2 prototypes alone cost $600,000 each, a sum that could have funded a small fleet of diesels. The full order for 52 T1 locomotives totaled $14 million, a wartime investment made with the belief that the duplex design would solve the capacity crisis and secure the railroad's future. Every dollar spent reflected not just hope in new technology, but a calculated risk that the T1 would outpace both rivals and history itself. By 1953, the Pennsylvania Railroad made its decision. Every T1 locomotive was pulled from service, their careers cut short after barely a decade on the rails. The order went out: scrap the fleet. In 1956, across yards from Altoona to Crestline, the work began. Maintenance crews and yard workers, some of whom had spent years fighting to keep these machines running, now faced a different task. Oxyacetylene torches hissed to life, slicing through the shark-nosed streamlining that once symbolized hope and speed. Steel panels fell away, revealing the complicated machinery beneath: gearboxes, rods, and the remnants of an ambitious dream. There was no ceremony, no preservation effort. Each of the 52 T1 locomotives was reduced to scrap, piece by piece, until nothing remained but piles of twisted metal and fading memories. For the men on the ground, the work was dirty and relentless. They cut apart engines that had been the pride of the line only a few years before. There would be no museum display, no survivor to tell the story in steel and rivets. The T1 vanished completely, leaving behind only photographs, technical drawings, and stories passed between those who remembered. In their absence, questions lingered about their true potential, their failures, and the speed records that could never be proven. The legend would have to live on without a single engine left to examine. Rumors of the T1's top speed have fueled debate for decades. The most persistent claim, 142 miles per hour between Crestline and Fort Wayne, rests on the account of a Franklin Railway supply technician, stopwatch in hand while recording times in a notepad, yet no authenticated record survives. The T1's own speedometer, an analog dial designed for the era, maxed out at 120 miles per hour. Any speed beyond that was invisible to the crew. No Pennsylvania Railroad document, no official test log, and no contemporary newspaper ever confirmed a figure above the design limit. Oral histories and secondhand stories fill in the gaps, but the evidence remains circumstantial. Historians sift through fragments, including a technician's calculations, memories from retired engineers, and the persistent absence of hard data. The legend persists, but without modern instrumentation or a surviving locomotive, the true peak speed remains an open question, one that only a new test could hope to resolve. In 2014, a new chapter began as the T1 Trust set out to construct Locomotive 5550, an exacting recreation of the lost T1, built with the benefit of modern science. Engineers and volunteers pooled expertise, drawing on advanced computer modeling and using high-strength alloys that far surpass anything available in the 1940s. Every component, from the massive wheels to the intricate poppet valves, is being designed for both authenticity and resilience. The goal is clear. By 2030, 5550 will undergo instrumented, controlled speed trials, collecting comprehensive data. For the first time, the T1's capabilities will be measured against the Mallard's officially recorded 126 miles per hour. What was once rumor and legend is becoming a testable hypothesis, with the world watching to see if the new T1 can finally claim the crown of the fastest steam locomotive. Today, engineers and dreamers rebuild what industry once abandoned, not just to chase a forgotten record, but to test the edge of innovation once more. As steam's legacy returns in steel and steam, the real race is against time, and whether we dare to learn from ambition's cost. What is your verdict?